All right, we're going to keep moving along here, and these get a little bit harder as we go. So I'm glad that you're going to have this video to refer back to in case you forget how to do them. You don't have to try to remember what I said in class. You can look back at the video if you need to. So this one gets a little harder, and the reason they get harder now is because, as you can see, there's a square root on both sides, okay? So we're going to have to be careful when we look at that. Sometimes that makes us have to factor. So let's do what we know to do, which is to isolate the radicals as much as we can. And I can see that that's done. It's already a square root on the left and just a square root on the right. Well, I can use opposite operations. I know that the opposite of square rooting something is squaring it. So I'm going to go in here and I'm going to square both sides. And that gets rid of my roots, okay? So that square root and squared cancel each other out, and I get u minus 8 equals. And here, the square root and the squared cancel each other out, and I get 43 minus 2u. So that's awesome. That's not so bad now. Now I just need to solve. I need to get my letters on one side and my numbers on the other so that I can solve for just u. So I think that I will, let's just, well, it doesn't matter how we do it. Let's add the 2u to this side. That gives me 3u minus 8 equals 43. And then I will add the 43 to both sides, or excuse me, add the 8 to both sides. So 3u equals 43 plus 8 would be 51. And when we divide both sides by 3, u equals 17. But again, we need to do a quick check on these. So I'm going to make sure that works. So let's check it. The square root of 17 minus 8, does that equal the square root of 43 minus 2 times 17? Well, the square root of 17 minus 8 is the square root of 9. The square root of 43 minus 2 times 17, that's 34. So 43 minus 34, that's the square root of 9 equals the square root of 9. And we know that that's true. So u equals 17 is good. All right, here I have fourth roots on both sides. I have the fourth root of 27 minus 2d equals the fourth root of d minus 3. So to get rid of that fourth root, I need to take both sides to the fourth power. So I'm going to take this side and raise it to the fourth. And I'm going to take this side and raise it to the fourth. And when I do that, the fourth roots are canceled out with the raising to the fourth power. Those are inverse operations. So I'm left with 27 minus 2d equals d minus 3. All right, let's, it doesn't matter which way you go, but I'll go ahead and just subtract the d. So 27, negative 2 minus 1 is negative 3d. Then I will subtract the 27. So negative 3d equals negative 30. Divide both sides by negative 3, and I get d equals 10. So let's check it real quick. So the fourth root of 27 minus 2 times 10, does that equal the fourth root of 10 minus 3? Okay, so 27 minus 20 is what I have on the left, and 10 minus 3 is 7 on the right. 27 minus 20 is also 7, so I'm left with the fourth root of 7 equals the fourth root of 7. And no matter what I do, I mean, if I stick that in the calculator to get a number, that's fine, but they definitely equal each other anyway. So it's fine. We don't have to try to get the exact answer there. We just have to know that they equal each other. All right, number 11. I've got a 4 outside of my square root on this side, and I've got a 12 outside of my square root on this side. So I think the way I'm going to start this one is I'm going to try to divide by 4, and it gets rid of it off the left. I know it doesn't get rid of it off the right, but let's still try that anyway and see where we get to. Okay, square root 3q plus 15 equals 12 divided by 4 is 3 square root q. Okay, so now I can't, there's nothing else I can do with this 3. There's nothing else to divide it out with. I can't do anything else with it. So I'm going to go ahead and try to square both sides, okay? Because I can't isolate it any further. There's nowhere else to go with that 3. So I'm going to square both sides. Okay, I just have to be careful on the right when I do that squaring. So on the left, the square root and the squared cancel each other out because it's all underneath the root sign. So 3q plus 15. But on the right, the 3 is not underneath the root sign. So it doesn't get canceled out with the root like the square root of q does. I actually need to take 3 squared because, like I said, it's not underneath the root sign. Well, I know that 3 squared is 9. Now for the square root of q, the square root of q and the squared cancel each other out, and I just get 9q. So let's subtract the 3q. So 15 equals 6q. Divide both sides by 6. And I know, let's see, 15 divided by 6. Both of those numbers divide by 3. So 15 divided by 3 is 5, and 6 divided by 3 is 2. So I get 5 over 2 equals q. All right, let's do a quick check on this one. 4 square root 3 times 5 over 2 plus 15, and that's all under the root, equals 12 root 5 over 2. All right, so this is 4 square root. This is going to be 5 times 3, which is 15 over 2 plus 15 equals 12 times the square root of 5 over 2. All right, you do some simplifying here a little bit further. This is the 4 times, and then I have 15 over 2 plus 15. Well, if I wanted to get that to be a common denominator, I could do that. I could also just do this in my calculator, which I'm going to show you guys do this on my calculator because 2 reasons. 1, I'm just checking, and 2, I can do all of this in the calculator and not necessarily worry about it, and I'm going to run out of room. So the way you do that is do 15, type it in just like it is, 15 divided by 2, okay? And then add 15, and you get a number that's a decimal, but if you want to put it back into fraction form, you just go under math, and number 1 says take me back to a fraction, and I get 45 over 2. So I'm going to use 45 over 2 equals 12 square root 5 over 2. Got a lot going on here. Can I just type them in the calculator and see if I get the same number on both sides? Absolutely. I think that's going to be the easiest thing to do here. So I already know, well, I can check this. Okay, so I've got second square root 45. Let me do it right here with you. 45 divide 2, close my parentheses, okay? Square root of 45 divided by 2 times 4. I get 18.97. All right, let's hold that number, 18.97. All right, let's see what happens when we do the other side. Second square root, 5 divide 2, enter, times 12. 18.97. Okay, I got it. It's the same thing on both sides. So I just wanted to do that because I wanted to point out to you guys that if you do get one where you're supposed to check it and it does get kind of ugly to check it, just use your calculator. You can tell if you get the same number on both sides when you go to simplify it. I'm okay with that, all right? You just need to make sure you check them so that you know that they work, because if no solution is the answer and you put an answer, then you're going to get it wrong. So, all right, let's go on to number 12. All right, I've got cube roots. I ideally would probably need to get this -2 out of there, but I don't have anywhere to go with it because it doesn't have anything to divide by on the other side. So I'm just probably going to have to cube both sides, and I'm going to have to cube it. Okay, So cube both sides. And the reason I'm cubing is because cubing is the opposite of cube rooting something. So the cube root and the cube cancel each other out, and I get 14 minus 10n equals. Now, I have to be careful here. This 3 has to go onto that negative 2. I'm going to write it out so you can see it. It has to be negative 2 cubed, and then cube root of n and the cube root cancel each other out, so that's just n. So this simplifies to 14 minus 10n equals negative 2 times negative 2 is 4, times negative 2 is negative 8n. Okay, let's add the 10n. So 14 equals negative 8 plus 10 is 2n. Divide both sides by 2, and I get 7 equals n. All right, quick check. I've got cube root 14 minus 10 times 7 equals negative 2 cube root 7. Okay, so let's see what's going on here. 14 minus 70 equals negative 2 cube root 7. All right, so that's cube root of 14 minus 70. I think that's negative 56. 14 minus 70, negative 56 equals negative 2 cube root 7. Oh, I don't like that. Let's just type in the calculator and see what we get. I think that's easiest, and I think that if you guys will do that, that will be a good check for these. So on the left, I have the cube root of negative 56. Well, under math, down to 3. It's also, you can do this in Desmos too. Desmos has a cube root. Desmos has an any root. Negative 56. And I get negative 3.825. Now on the right-hand side, I've got the cube root of 7. So let's do that first. Cube root of 7. And then multiply it times negative 2. Negative 3.825. I got the same thing. So this one checks. Okay. All right. Well, this guy, number 13, looks pretty easy, right? But it actually has a little bit more work we need to think through as we go do it. So this is the square root of 8x equals x. So the first thing I need to do is get rid of that root. So I'm going to square both sides. So on the right, the square root and the squared cancel each other out. 8x equals, x squared. Okay, so that's why this one's a little bit harder, because we end up with this x squared that we have to think about. And this is 8x. There's a b term. We can't use the square root formula, the square root property, and just square root both sides if there is an x there. I can't do that. So I'm going to have to move this guy over to the other side. So let's subtract 8x over here. So 0 equals x squared minus 8x. Now I'm going to have to factor this. And so I look for a greatest common factor first. And what I see here is that you can take an x out of both of them. So 0 equals x times x minus 8. When I factor out an x, I took an x out of both terms. When you do that, this is what you're left with. And now we solved these equations. We did all of this before Christmas. We spent like a month solving quadratics. So the first thing, we did lots of these where the first thing you have to do is take out a GCF. And now you set both pieces equal to 0. So this is x equals 0. And this one is x minus 8 equals 0. So x equals 8. So now I just have to do a quick check on both of my answers, because I got 2 answers and one might work, or they both might work, or neither might work. I don't know what the deal is here. So I'm going to check first the square root of 8 times 0 and see if that equals 0. Well, that's just the square root of 0 equals 0. And so that one does for sure work. So I'm going to go ahead and box that guy in. Let's check 8. So I'm going to have 8 times 8 underneath the root equals 8. Square root 64 equals 8. Oh, yep, it works too, because the square root of 64 is 8. So that one has 2 solutions that both work. You need to be sure to include both of them in your answers. Okay, so the square root of 12 minus a plus 7a equals 8a. Oh, so this one I can definitely get the square root to be isolated first. I can definitely get that guy to be all by itself. I can subtract the 7a over to the other side. So let's move him. And I get the square root of 12 minus a equals 8 minus 7 is 1a. So now I'm going to square both sides. And I have 12 minus a equals a squared. Okay, I have an a squared again. And I have a b term. So I'm going to get it all on one side, and I'm going to go over here to the right-hand side because I want my a squared to be positive because that's easier to factor, all right? So I'm going to subtract the 12 and add the a and set this thing equal to 0. So a squared plus a minus 12. And this has to be factored, okay, which is opposite of FOILing. All right, I should have said, check to see if there's a greatest common factor first, just like we did over here on number 13. But there is not a greatest common factor. So it's ready to be factored just like it is. Remember, it's opposite of FOILing. So to get a squared, I use a. And now I need two numbers that multiply to negative 12 and add, remember this, to 1. Multiply to C and add to B. Okay, multiply to C and add to B. C is negative 12, B is 1 here because there's a 1 in front of this A. That's the coefficient of A. So what are the two numbers that multiply to negative 12 and add to 1? Well, I think factors of 12 that might work here, 4 and 3, but one of them needs to be negative. Okay, and I need positive 1. So let's make the 3 negative. Okay, so positive 4 and negative 3. Now, set both of those equal to 0. A plus 4 equals 0, so A equals negative 4. A minus 3 equals 0, so A equals 3 when I add it over. All right, let's check. All right, I'm going to go over here and check in a different color so that's because stuff's getting kind of put together here. I'll also pull this around because this was my factor information. Okay, so I'm going to check negative 4 first. So when I do the square root of 12 minus negative 4 plus 7 times negative 4 equals 8 times negative 4. All right, let's do some simplifying here and see what happens. Okay, so this is the square root of 12 plus 4, which is 16. Minus 28, 7 times negative 4, equals 8 times negative 4 is negative 32. Square root of 16 is 4. Minus 28 equals negative 32. Well, what is 4 minus 28? 4 minus 28 is negative 24. That does not equal negative 32. So the negative 4 one doesn't work. Okay, let's try the 3. So I'm going to check the 3 now right here. So I have the square root of 12 minus 3 plus 7 times 3 equals 8 times 3. Square root of 12 minus 3, that's the square root of 9 plus 21 equals 24. Square root of 9 is 3 plus 21 equals 24. 24 equals 24. A equals 3 works. All right.